Our lesson today about transformer calculation. As we said before, we have two types of transformers, step-up transformer and step-down transformer. And the step-up transformer increase the potential difference of an electricity supply, whereas step-down transformer decrease the potential difference. If we know the potential difference in the primary coil and the number of turns in the primary coil and secondary coil, then we can calculate the potential difference in the secondary coil. By applying the transformer equation VB divided BS equals NB divided NS, as we said before, the potential difference in the primary coil VB, potential difference in the secondary coil VS, number of turns in primary coil NP, and number of turns in the secondary coil NS. Let's solve the problems on this equation. Now let's see the first problem. A transformer has 200 turns in the primary coil and 50 turns in the secondary coil. A potential difference of 48 volt is induced in the secondary coil. Calculate the potential difference in the primary coil. Pause the video and try to solve it by yourself. Now let's see how to solve it. First, we are going to arrange the equation, and the equation will be Vp equals Np divided Ns multiplied by Vs. So Vp equals Np equals 200. From the problem here, transformer has 200 turns, so Np equals 200 turns, and the Ns equals 50 turns, the secondary coil, multiplied by Vs, which is the secondary voltage, 48. So Vb equals 192 volts. Let's see another problem. A transformer has 100 turns in the secondary coil. It steps up a potential difference from 50 volt to 250 volt. Calculate the number of turns in the primary coil. Pause the video and try to solve it by yourself. Now let's see how to solve it. First, we are going to rearrange the equation. So NP equals Vb divided Vs multiplied by Ns. We have Vb equals 50, Vs 250, Ns 100, and Nb will be equals 20 turns. One very important idea about transformers is that the power must be conserved. This means that the power of the primary coils must be equal to the power of the secondary coil. This means that Vb multiplied by Ib. What is Ip? Ip is the current in the primary coil, must be equals to Vs multiplied by Is, and Is is the current in the secondary coil. This only applies if the transformer is 100% efficient. In other words, no energy wasted. In practice, that won't be the case, but for calculations, we can assume that it is. Now let's solve a problem. A transformer has a potential difference of 200 volts and a current of 0.1 ampere in the secondary coil. The potential difference of the primary coil is 50 volts. Calculate the current in the primary coil. Try to solve it by using the previous equation. Okay, so pause the video and solve it by yourself. Now we can rearrange the equation. So Ip equals Vs Is divided Vp. So Ip equals Vs Is divided Vb. So Ip equals 200 volts multiplied by 0.1 ampere divided by 50 volts. So Ip equals 0.4 ampere. Thanks for listening and goodbye.